Let's take a virtual site tour through the Sokli mining project. Now, this project is owned by the Finnish Minerals Group, and they are the Finnish government's holding for the mining industry and the battery value chain. They create sustainable businesses and they have active ownership around these projects. And they're looking to provide materials for climate neutrality for that energy transition, providing those critical minerals that we all know to be so important. And the effect of this is ultimately to really contribute to Finnish independence, and not just Finnish independence in the battery value chain, but also Europe's. So there's a lot of potential here, and it's really exciting. Let's look at their portfolio. The one that we're going to be focusing on today is Sokli. You can see it's 100% owned by the Finnish Minerals Group. Now, where is this project? It is in the northwest part of Finland, so right here. And if we dive down into the project, you can see their mining leases here are well connected on the infrastructure front. So we've got roads running right through the property. If we step back really quickly and look at the timeline, it's really interesting. So the Sokli carbonatite complex is one of the largest of its kind in the world, which is really cool because they are very unique deposits, which we will get into in a minute. But you can see here, it was discovered in the 1960s. It's had a long history of extraction, primarily for phosphate and iron. And therein lies the opportunity, which we'll get to in a minute. But first, I'd like to show you what the area looks like. So this part of the world, beautiful, flat topography, exactly what you'd expect for Finland. This is the overview of the deposit area, and you can see there's lots of infrastructure in all directions. Now, what does some of the historical workings and tailings look like? Well, you can see it's been completely restored to its natural state. The vegetation you can see on the surface here is all natural. And then their camp can sustain 6 people. They use the existing old pilot plant here to store their core samples. Now, if we step down into the 3D model, let's talk about carbonatites. So they are incredibly unique deposits. They typically look circular in shape. They're an igneous rock, but what's interesting about them is their chemistry. Their very unique chemistry allows for them to contain quite a few really rare minerals and elements. And again, I think I mentioned up until this point, Sokli's only really been looked at for phosphate and iron. There's the potential for uranium, thorium, manganese, vermiculite, but also niobium, tantalum, and rare earth elements. Now, you may have heard of these before. They're incredibly important critical minerals in really, really high demand. They're very rare, and carbonatites are one of the leading sources for these elements. Now, you can see here the mapped volume of rock is huge, 9-kilometer strike length. You can see this magnetic core in the middle here corroborates the interpretation of the deposit size. And if we look at the actual magnetic susceptibility, their geophysical study, you can see that that layer of data corroborates that volume as well. Now, if we look at the actual numbers, here's the resources and reserves. Again, you can see they're only considering phosphate and iron. Right now, what Sokli is trying to do is actually quantify with a feasibility study what that additional reserve looks like for those other commodities, which is really exciting. So what does the ore actually look like? Well, here you can see this green unit here is called phosphorite, and that's the sweet stuff. That's where the juicy, interesting minerals exist. You can still see it's still upholding that sort of circular volcanic pipe or core. And all of the drilling here, you can see it's been really well done. Lots of confidence here and control on the deposit volume and geometry. Now, if we keep looking here at the core, it's a beautiful core. We zoom in, you can see all of these beautiful dark bits are where things get really exciting with the rare earth elements, niobium, tantalum, etc. Coming back up to the actual mining scenario, there is a lateritic surface to these deposits. And what that looks like is exactly what you'd expect from a sort of weathering scenario. It's loose, it's semi-unconsolidated, easy to extract those minerals. And they've got a second pit over in this part of the deposit over here. Now, this isn't the only extraction method. There is other extraction methods possible that they're looking into right now, metallurgically and flow sheet wise, deeper down in the deposit. Coming back out again to get the scale of all those different rock types and the scale of the deposit, you can see that it's extensive. Now, their processing plant has already been designed and rendered. If we dive down into it, you can see what that looks like. We're not going to get into the flow sheet here. Coming back up and looking at what they're doing as far as due diligence goes on the environmental side. All of these different blue dots represent water sampling locations for their baseline studies. And they're also making sure to do everything they need to on the archaeological side. And this lines up with what their permitting schedule looks like, which is here. And if we step back out and just quickly talk about the potential for all of these different commodities. Now you can see that we've got phosphate on here, we've got iron, we've got the other elements, but just a note here that rare earth elements is not a single commodity. It's a whole suite of elements that are incredibly important to the electric vehicle industry, other electrical applications. Pretty much every renewable energy scenario involves rare earth elements. So if you're interested in learning more about the Sokli project, please don't hesitate to reach out to Pasi Heino. He is their project manager. You can follow the Finnish Minerals Group on LinkedIn, and that's his information. He'd love to hear from you. Please reach out.